In this video, we're going to look a little bit more about rotations on the coordinate plane, a little different than some of the ones we've seen before. But first, let's recall the rotations that we do know. So the first rotation we ever worked with was a 90-degree counterclockwise rotation. Now remember, primarily, rotations will always happen counterclockwise, but always read just in case. So in that first exercise, we're taking this AB and we're finding the segment A prime B prime, which is the image after a rotation of 90 degrees counterclockwise. So we should recall that to find that, A prime is going to become -5, 1, while B prime is going to become 3, 7. We can determine that by simply turning our page counterclockwise. We're rotating around the origin. So we're just turning our page from this spot. So that's how we get those points. So -5, 1 is here. B prime 3, 7. And we're going to connect that line to make our segment. And what we should notice is I could look at the slopes of these two lines if I wanted to. And if I did do that, I would see like AB, it looks like it's down 4/3. I can check that, it checks out. So down 4/3, while I'm going up 3/4. Notice they're negative reciprocals of each other. Why might that make sense? Oops, excuse me. These lines would have to be perpendicular to each other because it's a 90-degree rotation. Perpendicular lines form those 90 degrees. So even though it didn't ask about that, just keep that in mind as we go forward. What we are asking, though, in part B is to determine the length of these two. So remember, to find the length of any segment, we're going to use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, and it's all under the radical. So in this case, we just plug in. Now, what we have to be careful of is while this is all under that square root, 7 subtract 1 squared, it's going to be 6 squared, which is 36, plus -3 subtract 5 more is -8. That does not get us -64 when we square it. Remember, squaring something means you're doing that double negative. So negative times negative is a positive 64. Which when we add that together, we get the square root of 100, which we know to be 10. Take a moment, pause the video, and do the same thing with A prime and B prime now. Welcome back. Notice that you still should have gotten the length to be 10. Even if you put your order of your points in a different order, like you had -5 subtract 3 and 1 subtract 7, that's fine as long as you stay consistent with the points. But either way, they're both 10. Why might they both be the same length? Like AB is congruent to A prime and B prime. Well, think about what kind of transformation this is. It's a rotation, and we should know that rotations preserve length and angle measure, but we just saw it in the length. Okay, remember it's a rigid motion. And just to remind ourselves, all counterclockwise rotations of 90 degrees follow the same rule. It's -yx. So we have the rule somewhere nicely. Okay, now 90 degrees isn't the only amount we can rotate, but we usually stick to the multiples like 90, 180, 270, and then 360, you remember, is a full circle. So that would just bring it right back to the beginning again, the same as not rotating at all. So in this case, I want you to think about something. If I rotated 90 degrees, if we start with xy and I rotate 90 degrees, we would have gotten -yx. Now, if I rotate another 90 degrees, that would get us negative x, negative y. Because think about it, I did it once for 90. If I do 90 again, I add up to 180. So now I'm going to do 180 counterclockwise. Now, clockwise versus counterclockwise doesn't really matter here because 180 degrees is like that perfect halfway point around, like it's a straight line. So if I go clockwise, if I go counterclockwise, it's really going to be the same. But let's see what happens. So basically, in this case, C prime, I'm changing the sign to 3, negative 8. And then negative 9, negative 2. Now let's see what that looks like here. Now notice a couple things. They're going to have the same length. We could use the distance formula again. We just saw that 90 degrees wouldn't change, 180 wouldn't either. But let's check out the slopes. So CD. I could do the slope formula. So maybe I will for the first one just to remind ourselves that the slope is the change in y over the change in x, otherwise known as y2 minus y1 over x2 minus x1. So if I looked at CD, 2 minus 8 over 9 minus negative 3, negative 6 over 12, negative 1/2 is what we end up with. Let's see if we get the same thing for C prime D prime. And now this time I'm just going to count my boxes and see if that checks out. Down 1 over 2. Yep, down 1 over 2 checked out the whole way through. So if that's the case, that means that CD is parallel to C prime D prime. Okay, they have the same slopes, which should make sense. Because if you think back to when we did constructions in the beginning of this quarter, we could construct a parallel line from a 180-degree rotation, okay, from a point. And that point in this case would have been the origin. Okay, so the rotation rule here is going to be negative x, negative y for 180 degrees. On the next page here, you'll see we do have a bunch of rules. We have 90, which we've already known. And remember, these ones are assumed to be counterclockwise. Okay, so if you see just 90 degrees, we're thinking counterclockwise. Over here with this little negative sign, that's clockwise because you're going opposite direction. Like that negative is really just talking about the direction. And counterclockwise is our basic version. Clockwise is the opposite. So instead of rotating 90 degrees counterclockwise, you'd be rotating 270 degrees clockwise to get to the same spot. It's just about direction. That being said, if I wanted to do 270, to get from 180 to 270, it's just another 90. So that would change this to y, negative x. And it would be the same as if I rotated clockwise 90 degrees. Okay, so those are the three possibilities. Usually it is 90, but it could have some kind of twist to it where it's 180 or 270. So we want to just keep those. As long as it's a multiple of 90, we're good. Now, there is one other scenario that can happen. We've always really rotated around the origin, but we could rotate around another point. And that's what we're going to see here in exercise D. In the diagram shown, we have ABC and point D. We want to draw the image of triangle ABC after a counterclockwise rotation of 90 degrees about point D. So this is the first time we're not using the origin as our point. That means we have to do something a little bit creative here to help us. What we're going to do is we're going to rearrange this and make D the origin for a second. Because we've been able to rotate no problem when we're rotating around the origin. So let's make D a fake origin, if you will. Which means if that's my origin, all these points, A, B, and C, are changing for a minute. So I'm going to write them down on the side here. So A, B, C. With the fake origin, if I look, we have -8, 0 as A if I'm counting from D. So these are my current points. What I want us to do here is now that we have like this fake origin intact, we're going to do the counterclockwise rotation to get the A prime, B prime, C prime. So let's rotate. 90 degrees, 0, -8. -5, -6, and +4, 4. So I just did the 90 degrees from this fake origin point. Now I'm going to plot those. 0, -8. Now from D though, this is all from point D. So here's A prime. -5, -6 from D is 1, 2, 3, 4, 5. 1, 2, 3. Oh, wait 1 second. I forgot. I counted one spot wrong here. This was actually a -5, which will make that a +5. So we're going to move B prime. Sorry about that. Just noticed that they were not in the same order. So +5 and then -6. That looks much better. And so that's our new points. To finish this off, to find our final answer here, now we write our points as where they actually are from the regular origin. So that means I'm counting from here. So A is over 4, down 1, 2, 3, 4, 5. B prime is 10, down 3. And C prime is 8, up 7. It's different, but if you make that fake origin, it's a little bit nicer. Okay. One more. So try to set this one up. Now we're doing 180 degrees clockwise. 180 degrees can go either way, but plot your points and try to make this fake origin, and you only have to do it for 1 point. You were able to get to this point. You knew that B was your fake origin, so we drew those lines in. We plotted A and B. We counted where A's new value would be, which is at -5, 12, which really means it's -5 and 12 away from point B, the origin, fake origin. And then I rotated 180 degrees. So that changes the signs to 5, -12. Now we get into the problem of not being able to draw 5, -12. It's somewhere way down here. But think about it. We're trying to figure out how far away from the origin it is, that fake origin. So you're trying to see from 2 and -5 how far away. So we just add those, which is choice 1. Okay? You're figuring out how far away each is from that fake origin. So you use that point the same way as an origin and then kind of dial it back into where that really is from and how far away from our real origin it is.